Alright, welcome to video 3. I meant to be 2 videos, but something screwed up. So here's the third video, truly the last one for the rest of the course. In this problem that's shown here, where it's another area example, and you might be tempted to do the same thing we did in this problem. You see you have a function x in terms of y, and what we did was in method 2 we swapped the x variable and the y variable everywhere. And you might say, oh, I'll do the same thing. I'll let y equal e to the x, y equals 0, and x equals e squared. And that'll be a simpler problem. I won't have to think sideways. And you'd be correct. That will absolutely work. No question. But you will get stuck at the integral step because you'll have to take the antiderivative of the ln of x, and you don't know how to do that. So I'll show you an alternative that will work for some problems. And that's rearranging it. So in this case, we can exponentiate. We can raise both sides as powers on a base of e. So e to the power of the left side equals e to the power of the right side. E to the x is equal to e to the ln of y. And the cancellation loss yields that y equals e to the x is the equivalent expression. And everything else is the same. Y equals e to the x is 0, y equals e squared. We did not swap x's and y's. Okay, we didn't do that. Step 1. That's kind of step 0. Step 1, make a sketch. Step 2, intersections. So for intersections, we're going to set y equal to y. So e to the x equals, we'll color code it. We'll circle x is equal to 0 in green. And we'll use blue for the y equals e squared. We're setting y equal to y. So one of the y values is e to the x, the other y is e to the 2. So now we're solving. E to the x is equal to e to the 2. Well, that means x is 2. That's our solution. When we make our sketch, we're going from an x value of 0 to an x value of 2. So I'll graph e to the x in red. Something like that. And then e to the 2 is just a constant. E is 2.7, so e to the 2 is 2.7 to the 2. So that's y equals e to the power of 2, a constant y value. And then I'm going to graph x is equal to 0 with green. And then shade in the area that we want to calculate. That's our area of interest. Now we'll do step 3, area integral. So the area is the integral from 0 to 2. Oh, yeah, 0 to 2 of the top function minus the bottom function. All right, well, what's the top function? What's the blue? It's e to the 2. It's a constant. That's okay. We're allowed to have a constant as the top or bottom curve. And the bottom is e to the x. Dx. All right. Now, I'm going to write something down just temporarily. What is the antiderivative of 3? That means what do you take the derivative of to get 3? And the answer is 3x plus c. What is the antiderivative of pi? What do you take the derivative of to get pi? Well, the answer is pi times x. plus c. What's the antiderivative of e? That's just e times x plus c. What's the antiderivative of, let's say, pi squared? It's pi squared times x plus c. So pi is a constant, pi squared is a constant. Okay, antiderivative of e squared is just e squared times x plus c. So all of these things are the reasons for the next line that I'm going to write that's going to make you mad, that the antiderivative of e squared is e squared times x. Antiderivative of e to the x is just e to the x. And then we're going to evaluate this from 0 to 2. Okay, so we plug in the top bound. We get 2e squared minus e squared. Plug in the bottom bound. We get 0 minus 1. Two e squared minus e squared, so 2 of something minus 1 of that thing is just 1 of that thing, so e squared minus minus plus 1 is our answer. It's kind of a beautiful question. Kind of. Maybe. Okay, maybe not. Alright, this is the last, no, second last one. Find the area bounded by x times y is equal to 4 and x plus y is equal to 5. You got two choices here. You can think sideways or you can think not sideways. So if you want to, you can write this as x is equal to 4 over y and x is equal to 5 minus y. And then switch all the x's and y's. You can go through many different formats to solve this, but I'm going to do it the simplest way. In the first expression, I'm just going to divide both sides by x, so 4 over x. And in the second expression, I'm going to subtract x from both sides. So y is equal to 5 minus x. And then go through the steps as before. So step 1, create a sketch. Step 2, look for intersections. Look for intersections, we set y equal to y. So we have 4 over x equals 5 minus x. I'm going to multiply both sides by x. So 4 is equal to 5x minus x squared. Add everything to the left-hand side. X squared minus 5x plus 4 is equal to 0. And then factor. We have x. This factors into x minus 4 times x minus 1. And we get two solutions. X is 4 and x is 1. Okay, so that's going to help us identify regions of the sketch that we have to care about. We're going from an x value of 1. Should space it a little bit better. From an x value of 1 to an x value of 4. Okay. So x-axis where it always goes, y-axis where it always goes. And now I'm going to draw the red curve, 4 over x, by plugging in some numbers. So I'm going to plug in 1. When x is 1, I get a y value of 4. When x is 2, I get a y value of 2. I'm not going to do 3. I'm going to do 4. I get a y value of 1. I'm just going to avoid the fractions. And you can kind of get an idea what the shape is. It's doing this. It's a hyperbola. Okay, now I'm going to do the graph for 5 minus x. I know that it crosses at 1 and at 4, so I'll make sure it happens in the picture as well. And it's a straight line, slope -1, intercept 5. So intercept's up here. It's not going to be a very good picture, and that's okay, it doesn't matter. And then there's my area. That little sliver there. Okay, step 3. Area integral. Area is the integral from 1 to 4 of the top function minus the bottom function. So integral from 1 to 4. The top function is the blue one, higher y value, 5 minus x. The bottom function is 4 divided by x. Okay, now we can take the antiderivative. The antiderivative of 5 is 5x. Antiderivative of x is 1/2 x squared. And the antiderivative of 4 over x is 4 ln absolute value of x. And we're evaluating this from 1 to 4. Okay, let's see what this gives us. We gotta make sure that the outcome is positive. We get a positive number. 5 times 4, 20, minus 1/2 of 16, so 8, minus 4 ln 4, and then minus the bottom bound. So plug in 1, 5, minus 1/2, minus 4 ln 1, which is ln 1 is 0, minus 0. And then collect like terms, simplify. 20 minus 8, 12, 12 minus 5, 7. So I have 7 minus 4 ln 4 plus 1/2. And then let's see, what can we do? We have 7 is the same thing as 14 over 2, so 15 over 2 minus 4 ln 4. So comment. I get nervous when I see outcomes like this, because I really want to make sure this is a positive quantity. Now I know what ln 2 is. It's approximately 0.7. I've memorized that. There's more decimals after, but 0.7 is good enough. So 15 over 2 minus 4 ln 4. I'm going to show you a trick for estimating quantities. If you know a little bit, like you have to know something about ln 4 or ln 2 to do this. This is equal to 7.5 minus 4 times the ln of 2 to the 2, which is 8 ln 2, using log properties. So 7.5 minus 8 times 0.7. This is approximate. 7.5 minus, so 8 times 7, 56, so 0.56. Sorry, 5.6. What am I doing? 5.6, which is positive. So we were okay, possibly correct. So I'm happy. I can sleep well knowing that I posted this online and the answer is not negative. It could be wrong. I could have made a mistake in the evaluation on the bounds. But at least the outcome, the final answer, is a positive final answer. Okay, last question. Find the area of the region bounded by y equals 6x to the 5 and y equals 6x. Step 1 is a sketch. But we all know now that the real step 1 is finding the intersection points. Okay, so we set y equal to y. And that means might as well color code them now. So red, 6x to the 5, and then blue, 6 times x. Please do not cancel x on both sides, you'll throw away a solution. Instead, subtract 6x from both sides. Now common factor is 6 and an x out. Now we have x to the 4 minus 1 is equal to 0. Now we get 3 solutions. There's 3 solutions hiding here. The first solution is x is equal to 0. The second solution is x is equal to 1. And the third solution is x is equal to negative 1, since negative 1 to the power of 4 is positive 1. So our sketch is going to be interesting. So the x-axis and the y-axis don't have the same dimensions on this particular picture, and that's okay. They don't have to. We can stretch an axis if we want, or shrink an axis. The first graph, 6 times x. Straight line, intercept 0, slope 6. But on this weird stretched graph, looks like a slope of 1. It's not, just the axes are different. And then 6x to the power of 5. So you have to imagine plugging in a number less than 1. Like let's say you plug in a 1/2. You have 6 times 1/2 to the power of 5. 1/2 to the power of 5 is 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is 1 over 32. 6 divided by 32, well that's small, but positive, so it's down here somewhere. So this part of the graph is going to look like this. And then do the same thing for the left-hand part of the graph. You can convince yourself the left-hand part of the graph looks like that. So this is one of those problems where we have 2 distinct regions. Area 1 and Area 2. And the question did not tell us that. Combination of looking at the intersection points and looking at the sketch tells us we have 2 integrals to do. So step 3, area integrals. We have 2 of them. Area equals the first area. We're integrating from -1 to the intersection point that's in the middle, 0, of the top minus the bottom. So the top is the red curve, 6x to the 5 minus the bottom curve, which is 6 times x. Integrate in the x direction, plus the integral from 0 to 1 of the top minus the bottom in the second region. So the top in the second region is 6x, and the bottom is 6x to the power 5. Alright, now let's take the antiderivative of all the pieces. Antiderivative of 6x to the 5 is x to the 6. Power goes up by 1, we divide by the new power. 6 over 6 is 1, so the coefficient in front disappears. Antiderivative of 6x, we have 6 times 1/2 x squared, which is 3x squared. And we're evaluating that from -1 to 0. Plus, this is just the reverse. Antiderivative of 6x, 3x squared, minus x to the power of 6. And this one's evaluated from 0 to 1. Okay, now we plug in the top bound, 0 minus 0. Subtract and plug in the bottom bound. 1 minus 3. Now for the second region, plug in the top bound, we have 3 minus 1. Minus, plug in the bottom bound, 0 minus 0. So this works out to 0 minus negative 2. So 0 plus 2 plus 2 minus 0. We get a total answer of 4 for the area. And that's it. So, what's left is just our final exam. We will have an online final exam. It'll be due on the exam date as originally advertised, April 17th, on the Friday coming up. Not that far from now. I guess is that 2 weeks? Yeah, it's 2 weeks from now. It's multiple choice, open book. It's expected that you'll make a study sheet. That you will not be flipping through your textbook or trying to flip through PDF slides to look for something. Make good study notes, like several quiz cheat sheets. I recommend preparing for this exam the same way you prepared for our in-class quizzes, by making study notes. You don't have to cram everything in. You don't have to write super small. You can space things out and use lots of paper. But I highly recommend not relying on your ability to find what you need or what you want from the textbook or from a big stack of PDF notes, because you will waste tons of time doing that. Make good notes. There will be some form of flexibility regarding the start times. So even though it's nominally a timed exam, it doesn't mean everyone has to start at the same time. So yes, someone may decide to start in the afternoon, someone else may start in the morning, and that's fine. We want flexibility. This is supposed to be a 3-hour exam. We're going to set an exam that would be given in a 3-hour period if it was done in class, but everyone will get extra time. I do not know how much extra time right now, but my promise is that extra time will be given in either a direct extra time. So, I don't know. I don't even want to say a number because I don't want someone to come back and say, but hey, but you said blah, blah, blah. No, I'm not going to do it, but extra time period. Or we'll take an exam that's meant for 3 hours and we'll reduce the question number by some amount, and then still give 3 hours, but give fewer problems than we would normally give. So one way or another, we're going to reduce the stress that comes from the exam being timed. When I know more details, I'll post them. Anyway, good luck. I wish we could have had a proper end to the course, and I could have said goodbye to you face-to-face. Wish you good luck face-to-face. This is the best I can do. Almost. I actually can say good luck face-to-face, and I can say goodbye face-to-face, because I plan to have a review session streamed real-time in the week of the final exam. So I have a tentative date, but I'm not going to announce it until it's finalized. It'll be in the evening, and one of those evenings that week, I will record it. I'll post it the same way I posted all these videos. And the format of it is I'll have a few questions I want to go through on my own, and then I'll take your questions. All right? Good luck.